Hello everyone, this is S. Purushottam Rao. Now, uh, I would like to discuss about constructability analysis. So that is learning concept 1 from unit number 1 in project administration and safety management. Now coming to the concept, imagine a small residential project where the architect designs a basement parking with very tight column spacing and low floor height, and only after excavation the contractor realizes that the standard concrete pumps and formwork systems cannot be used safely or efficiently on site, forcing expensive redesign and delays. So this is again where constructability analysis reviewing designs with construction methods, equipment, and site constraints in mind. Now, definition and significance. Constructability is the process of integrating construction knowledge into planning, design, and execution phases right from day one. Uh, so, it is nothing but the process of integrating construction knowledge into planning of the structure, designing of the structure, and execution phases during the construction, right from day one to the end of the work. Why this matters? To prevent claims and disputes, which anticipates construction challenges before they become expensive problems, and reduces owner exposure. Owners avoid costly field changes and design errors. Industry recognized opportunity. The Business Roundtable identified it as one of the most significant cost effectiveness opportunities in construction. And another one is applies to all project sizes, whether you are building a small warehouse or 100 crore commercial complex or any type of infrastructure. It applies to all project sizes from a small project to the large projects. Now, coming to objectives and benefits of constructability analysis, there are four core objectives. First one is improve project outcomes in terms of better cost or economy and schedule of the work. So no delays and the quality of the work improves the quality of the work. Second one is minimize delays and claims. Foresee challenges before they impact timelines. The third one is enable collaboration. It's a very important objective. Unite owners, designers, constructors, and all stakeholders from the starting of the work to the ending of the work. So, collaboration plays a crucial role in project administration, collaboration and coordination also. The fourth one is enhance communication, uh, reduce misunderstanding between project teams. There are various teams in the project: planning and designing team, execution team, inspection team. So, reducing misunderstandings between all teams plays a crucial role in the project administration. Now, coming to benefits, uh, it reduces costly design errors and field rework, improves schedule reliability and punctuality in the project, and reduces owner claims by 30 to 50 percentage uh, from the starting of the project to the ending of the project. Enhances safety, efficiency, quality, and cost effectiveness across the board. Now, coming to core principles, there are four core fundamental core principles. One is involve construction discipline from day one. Uh, Construction engineers sit at planning meetings, not on sidelines. This means the project team should include people with site or field experience right from the first planning and concept discussions, not only after drawings are finished. So here the coordination is very important from starting onwards, not after completion of the drawings. So that is the meaning of this. Their practical knowledge about methods, equipment, labor, and site constraints helps to shape a design that is actually buildable. And not a review process, active participation in decision making. Constructability is not just checking drawings at the end and giving comments. Instead, construction professionals help decide things like structural systems, sequencing, access, and temporary works as part of the design process. They co own the decisions instead of only reviewing them later. The second principle is ensure a full participation in planning and design sessions. Constructors, site engineers, equipment specialists all contribute their ideas. Good constructability requires multiple field perspectives. The contractor or constructor understands overall methods and risks. Site engineer know daily practical issues like layout, staging, and coordination. Here, in terms of coordination is very important aspect in construction projects. Uh, Equipment specialists know crane reach, pump locations, lifting limitations, etc. When all of them speak in design meetings, more realistic and efficient solutions match. Their field experience informs design feasibility. And next one is conduct brainstorming for alternatives. There are multiple ways to build something. Explore options early. Almost every element like a slab, a footing or foundation, a retaining wall, parapet wall, whatever, maybe from foundation to the slab level, can be built in more than one way. There are many ways. Brainstorming early allows the team to list alternatives. Next, uh, evaluate which approach best balance time, cost, and quality. Very important principle. Very important. Time, cost, and quality. These are the very important aspects in any construction projects. Once options are listed, the team compares them against project priorities. If schedule is critical, choose methods that reduce time, even if slightly costlier. If budget is tight, choose methods that reduce cost without harming quality or safety. If performance is crucial, select higher quality systems that justify life cycle costs. So the structural comparison leads to a deliberate, not accidental choice. The fourth core principle is make trade-offs before finalization. That means compare options quantitatively. Trade-offs should be supported by numbers, not only opinions. Direct cost, time impact, quality, and long-term performance. Decide on time versus cost versus quality at design stage, not at site. So we should make decisions uh, at the design stage only in terms of time versus cost versus quality, not at site. So if these decisions are postponed to the construction stage, the changes become as more expensive, more disruptive, more expensive in terms of rework, redesign, variation orders leads to the more expensive, and more disruptive means delay of work delays, disputes between stakeholders, and claims, okay, from the contractor. Okay, so these two are expensive and disruptive. When the team finalizes designs after consciously choosing the preferred balance of time, cost, and quality, these three aspects, the drawings reflect realistic, constructible solutions. Site execution then follows a well thought out plan instead of improvising under pressure. Some trade off examples are given here. Uh, the first one is time versus cost example, crashing schedule. Example, to finish a project 2 months earlier, the contractor adds night shifts and more equipment. Benefit is meets a strict deadline, avoids liquidated damages, may earn early completion bonus. Now coming to trade-off, labor, equipment, supervision, and rework cost rise. Overall project cost increases. That is the cost impact. So here, that is one example of time versus cost. Now coming to time versus quality. To open a commercial complex before a festival season, finishes are installed quickly with less curing time for concrete and pure quality checks. Benefit, owner gets revenue earlier. Project seen as on time. Trade-off, higher risk of defects, cracking, leakages, poor finishes, and more maintenance rectification later. So that is the trade-off in time versus quality. Now coming to another example, cost versus quality, materials and systems. Designer specifies high performance windows and waterproofing. Contractor proposes cheaper alternatives. Benefit is immediate capital cost saving while opting such cheaper alternatives. Helps stay within budget because cost is less. But here, coming to trade-off, more heat gain, leaks, or deterioration in a few years because those are cheap materials, leading to higher operating and repair costs. So these three are simple examples of trade-offs. Now, implementation strategies and barriers. Uh, Most effective implementation approaches are, the first one is design build model. For any project, any industry, construction industry, so single entity handle design plus construction. That is very best for constructability. Next one is integrated project delivery. All stakeholders, all stakeholders means contractor, client, engineers, supervisors, designers, planners and designers, all workers, all stakeholders share risk and rewards equally. The next one is professional construction management, bridges the design construction gap. That is very important strategy. Early contractor involvement. Contractor advises during design phases. Now coming to conclusion. Constructability analysis is not just a nice to have, it's a professional responsibility as construction administrators. When you involve field expertise early, foster collaboration, and make informed trade offs at the right time, you deliver projects that are buildable, safe, cost effective, and on time. Thank you.